Well, hello folks, and welcome back to La Coco Strangiato. I'm Coconut Bob, and in this video I'll be discussing the final, or more accurately the first part of the HDMI onboard process, specifically connecting to the motherboard's RGB port. I'll show you the options I explored and the solutions I figured out to simplify the process, and then we'll take a comparative look at the final outputs of the different devices I've tried and compare the pros and cons of these upscaling options. I have some cool things to share with you, so let's go. So here we're looking at my original prototype for a internal RGB to HDMI. As you can see, I've got the 6-pin socket here, literally just hardwired over to the top of the RGB port. And what I'm going to do here, I'm going to take this cable off. So the final remaining wire here is actually the power wire. It goes to pin 6 over here. That 5 volts is actually coming from this guy here. This gives me a permanent standby power that's always hot. And if I don't have a power supply that will provide that, if I'm just running off a PD supply or something, then it will also get 5 volts from the board through this diode here. So for now, I'm just going to cut this right here, it'll be fine. Okay, so to get this guy off the board, it's actually pretty easy. Basically, I'm going to stick a socket on the bottom there. And this is partly to protect that pin header, so when I take it off, it can still be a usable part. But mainly just to give me something to grab onto to pull down. So I'm going to prop this board up on something. Now, this is the magic. So what I have here is just a piece of solid core copper wire. Just going to set it on here and be patient. Just let that iron heat it up. You can see the solder is melting on everything down here. Come on. Okay, that didn't help. That came off a little bit too easy. Alright. Try some more. You can always add more solder to this, it'll actually help. Get everything good and hot. And voila. So now we just have to clean up all that excess solder. All right, that actually went pretty easy. Now we'll just drag some solder wick over these, get rid of the excess, clean it up a little bit. Check the bottom. Actually looks fine. Okay, so here you can see my second version of how this would work. I've got my nice thin flexible HDMI cable running underneath. This unit has an RGB to SCART to HDMI converter under the board, and the cable here has a pin header on top of the board. This is just basically pins all the way down. There's still pins on the bottom as well. The signal comes out of the color computer right here on this ribbon cable, so that's a little bit more convenient than having wires soldered directly to the board. Well, what happens is when you have pins coming out like this on the top side and you plug in pin 1 here is actually the second wire in. So in order, the pins are kind of swapped every pair. So it goes 2, 1, 4, 3, 6, 5, 8, 7, 10, 9. And you have to remember that when you're hooking up the other end. It's a little bit confusing. So that's what happens when you use the wrong gender on the wrong side of the board. And the way to fix that is to take off the male header and put on the female header. So I need to remove this right now, and it's probably not going to be very fun because it's just two headers soldered together. Well, let's just see. So the first thing I'm going to do is attack it with some desoldering wick and plenty of flux. I just dip the braid into the flux here. Kind of wipe it onto the board. And we'll just push this in. Try to soak up as much solder as we can. Doesn't look like I'm getting anything. Now, these pin headers are not super strong. Worst comes to worst, I can literally pull one pin at a time as I heat it up. But let's just see how that works right now. I'm going to try. Oh, that's interesting. So this isn't a dual row header, it's two single row headers. Which means it comes off a lot easier. Okay. That wasn't too bad. So I need to pull the screws out so I can get to the underneath of this board. I'm going to plug on a connector onto the bottom here, and I'm just going to use an old IDE cable. So now I can put a little bit of downward pressure on this, and I pull out the secret weapon here. So we just we're going to put that right there, put a bunch of solder on it. fill that gap. Trying to get enough solder globbed into there to touch all 10 pins at once. Looks like I've about got it. And boom. Socket out. So there we go. That is basically removed and ready to solder in the new header. But I'm going to go ahead and clean this up. A little denatured alcohol on a rag. And that looks a lot better already. Okay, so I got the old pin header removed, and this is the one I'm going to be replacing it with. It's a female on top, male on bottom, basically. So just going to go in just like that, and I'm going to go ahead. This is pin 6 here is the key. I'm going to go ahead and cut this with my flush cutters. I'm not going to cut it flush. I'm going to give it enough room to still solder that pin on the bottom of the board. So that's where I'm cutting it. Okay, I'm going to be careful to catch that and not let it go flying. Then I'm going to take the same pin that I just cut, put it in pin 6 on the female side, so that I have now created a keyed socket. So what I'll do is I'll push that all the way down, pull it up slightly, cut flush, and push it back in. There we go. This is going to go in here like so. And now I will flip this over and solder. So I have to just hold that in with my finger. Get a pin soldered. Alright, cut them both, 1 and 2. It's always fun when things move around while you're trying to solder. To rotate the board. The last 3 pins here. I guess it's still 4 because I did. There's enough pin there to solder, so yeah. Okay, so since I'm putting a female header on top of the board, I have to replace this. I have to replace that with a male plug, so I have some of these here. And I can't just crimp it on there because the pins won't match right. If you remember, we talked about the wires are swapped in pairs, so it goes, instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it goes 2, 1, 4, 3, 6, 5, 8, 7, 10, 9. And if I just crimp this on here that way, it'll be wrong. So first I'm going to take this off. This is not super hard, it's just got to be a little bit careful to not break the housing, although these aren't super expensive and they are readily available, but I always try not to break stuff. So this is, I mean, you can barely even see the seam here. There you go. Get them up past that little bump and you're good. Alright, so I can show you the difference here. As you can see, the first wire here goes to the far side, whereas the first wire here goes to the near side. So again, if we look at the board, this is pin 1 and this is pin 2. So these are all odds and these are all evens. First, let me get this off of here. These are a little tricky to get out, but it's not too bad. I like to just use the blade and work them up slowly. If you just yank them out, there's a tendency to pull the pins right out of the socket. Just slowly work it up out of there. Perfect. And this can be reused. So back into the parts bin. We're over there, that's fine. Now I could take these all apart and remove the solder and resolder the wires in correct order. That sounds like a lot of work to me. I'm literally just going to cut these pairs, not cut, but separate the pairs. Okay. So this is probably going to look horrible. So to help me with this, basically, I'm going to lay some tape down here. To help me hold these wires temporarily. So I'm just going to do a twist. That's basically all I really needed. I didn't even need that tape. Okay. And now that it's like this, all of these existing punctures line up with the existing socket here. So I'm just gonna lay them right there, press them down with my finger. Take something round, just press them down. And there we go. This is ready to go now. Okay, so to do the internal SCART to HDMI inside a color computer, basically I start with one of these boxes, HD video converter, SCART to HDMI. And these are pretty commonly available. AliExpress, they're about 20 or 30 bucks. And they do a decent job. Not quite as good as the RGB to HDMI, or even a GBS control does a much better RGB output than this guy. But this device does alright, and with a custom interface board to get the levels right out of the color computer, it works pretty darn good. You don't need to spend hundreds of dollars or even $100 to get adequate video quality. I would say that spending $100 on an RGB to HDMI is worth it, but you can do this and you're almost as good a quality. So I'm going to go ahead and just pull this off. I have already modified this unit to be used internally. So what does that entail? Some of the things I have done, obviously I took off the SCART connector. This is actually not a simple task, and I would actually, this is like such a cheap socket that I would recommend just cutting it off in the future. I would not attempt to desolder one of these again. I'll just cut it with my flush cutters. So remove the SCART socket. It's not really necessary. It is possible to run a SCART cable inside the case, but it's a hassle. In terms of neatness of installation, this is much preferred. In terms of ease of installation, that's probably a little bit easier just to use a SCART cable, but you're still going to have to do plenty of soldering. So I don't know, it's a trade-off. I like this method better, and you'll see why here in a second. So in addition to removing the SCART socket, I've removed the PAL NTSC push button because I'm never going to use a PAL source inside this specific color computer. I'm also never going to switch to the HDMI input. I'm always going to be on SCART, which is what it defaults to. So I've removed both of those switches. So the only one I have left is the output resolution. I don't really need to change that very often, but every once in a while, if I'm plugged into a certain display that doesn't accept a certain resolution, I may need to change it. Okay, the one other thing that I took off is this RCA socket. This is actually the SPDIF out audio, digital audio output. This is an analog output. I don't really need that on there either, but I kind of need this socket. I use this on the color computer motherboard on the bottom to get a composite video signal out to this board. So to actually get the color computer's RGB to this board, there is in fact a little schematic that you use. You get a basic SCART cable, and then you need to add a resistor and a capacitor in line with the RGB signals. So originally I had just kind of wired them in there loosely, but I couldn't really find a specific resistor value that gave me the color levels that I wanted or felt would be appropriate. So I ended up using trimmer potentiometers, and then these capacitors are what I had, and these actually don't work very well. These are just huge for the space that I'm trying to put them in. And I designed this little interface board here as a carrier for the capacitor and trimmer potentiometers. Here you can see one that I've actually put together, and I've got the trimmer pots on there, and on the bottom I've got these capacitors that will hopefully work as good as those electrolytics. We'll see. This is kind of still a prototyping process. I have tested the value of the capacitor, and I found that Rather than using the recommended 220 microfarad capacitor, I tried a 330 microfarad capacitor based on something that I read online, and it actually seemed to solve the problem that I was having, which was basically some of the levels were too high and it looked a little bit washed out. So one of the problems I had with this board, there's actually several. This is my first prototype and there's at least 3 different mistakes that I've made on here, at least. One of which is the pin spacing is wrong in the SCART connector, and another is the footprint of the capacitor I used is too small, so my capacitors that I bought won't even fit on there. So that's why I went with these that fit nicely on the bottom. What else did I do wrong? Well, these pots probably would have been better 90 degrees rotated. Obviously a corrected pinout for the SCART, and maybe a better header, maybe an actual 10-pin plug-in header for the RGB cable, so I could just use a straight through 10-pin. But that's neither here nor there right now. What I'm going to show you right now is basically how to connect one of these boards to this board. And the fact that it's all kind of misaligned and not a proper fitment makes it a little tricky for us, but I'm going to show you how I deal with this. So part of the trick is I use these headers, and I just pull the pins out, and I will literally solder these pins in the board in between the 2 boards to hold them. So like, let me take one of these here and I'm just going to put it right here in this ground. That's not ground. Got this little arrow here, that's pin 1. So 2, 3, 4. Pin 4 is the audio ground. 5, 6. So 2 and 6 are left and right, and 4 is audio ground. So what I'm going to do is just start with one of these ground pins. I'm just going to stick it in the board like so. Solder it. I'm not really worried about the alignment just yet. Okay. So those pins just slide up into the board like so. I want to make sure I line these up so that they are spaced correctly. Come on. Okay. Good. So I'm going to melt this one just so I can tweak that alignment. There we go. So now that I have the 2 pins in, I can see that they're just slightly spread out at the top. Alright, I'm going to solder that second pin on. And for now I'm just soldering onto the actual converter board. I'm not soldering my adapter. Now that I have 2 pins in place, I'll go ahead and solder my adapter board, and I'm going to lift it up slightly. Okay. Take another pin here, go to one of the grounds. Oh, I see what's happened. Apparently I lifted that trace on the bottom of the board, so I'm going to have to solder this one in here. That'll be fun. Plenty of room. Okay, it's fine. I mean, that's basically it. I don't even use all of the pins, just about 12 or 13. I do need to still add a 100 ohm resistor right here. And then I need to add my composite cable along with the audio and video cables. Okay, so next, what do I have? Here we go. Got a composite video lead. So originally I made this board for this to solder right here, and it comes over to this pin and pinned down to the bottom. I'm just going to solder directly to the board though. Why? Because more connections is not preferable to less connections. That is secure. Okay, the only other thing I really like to do to this is maybe shorten the LED leads. We don't really need all this excess there. It just kind of gets in the way. But I don't mind having an LED on the board to let me know when, basically lets me know when I have my standby power active. So there we have it. This is pretty much ready for installation, other than just hooking up the 10-pin connector to go from here to the RGB port. So here you can see basically the finished board. I've got my adapter board installed and all wired up to the RGB cable. This particular cable is one that I've one of my experiments, and basically I wanted to run a ribbon cable. I normally prefer to run a shielded cable, but I wanted to test the concept of running a ribbon cable where I've got a ground wire in between every signal line. So this ground plane kind of just tucks in under one of the keyboard mounting springs, and this just plugs in like normal. So we'll see how this works out. So there's one final piece to the SCART puzzle, and that piece is what you're seeing here, artifact colors. As you may know, the RGB output does not support these artifact colors, and they just show up as vertical black and white stripes, which isn't very fun. Typically, the only way to see these colors is via RF or composite output. So if we take a look at the SCART wiki page, we can see the red, green, and blue inputs, as well as the composite input, which is required for sync. And we can see that pin 16 controls the composite RGB switching based on voltage levels. If you're not familiar with the Switch-a-roo cable, there is a 5-volt wall wart required to get it to switch from composite to the RGB input. And this is in addition to the SCART cable itself and the SCART converter box, which in turn needs its own wall wart as well. And in my opinion, this just seems like a silly amount of cables and power outlets just to get video into a monitor. So the question is, how do we get voltage to pin 16, and how do we switch it between 0 volts for composite and 1 to 3 volts for RGB? Well, it turns out there's not only an unused pin on the Coco 3's RGB port, but there's an existing switch that switches between ground, or 0 volts, and 8 volts. Slightly less with this inline resistor. Let's start by looking at pin 10 on the RGB port. As you can see, this pin has a pull-up resistor, R61, and a current limiting resistor, R62, which goes directly into this PIA channel. Nobody knows exactly what Tandy intended this pin for, as it was never officially implemented or supported, but this pin can be configured as an input or output, and it looks to me like it could have been used to detect the presence of an RGB monitor and possibly even control it. But again, this was never documented or implemented in any way by Tandy, so this is all just speculation. Now, all of that said, I feel it's fair game to use this pin for our own purposes, which in this case will be to send the control voltage to the SCART pin 16. So where do we get this control voltage? Well, from our old, all but useless friend, the channel 3/4 switch. If we look at the schematic again, we see that one side of the switch is ground and the other side is connected through a 100 ohm resistor to 8 volts. And the output of the switch goes to the RF modulator. So how do we wire this up? Well, we can see that R61 and R62 are tied together and go directly to pin 10 of the RGB port. That's these two vias here. So first we need to remove the 5-volt pull-up resistor R61, and if you want to be extra safe, remove R62 as well, though it really should be safe to leave that one in place. You can see that I have removed both from this board, and in fact I have seen Coco 3s that were missing one or both of these resistors from the factory, so your mileage may vary. Now we just need to run a wire and a 150 ohm resistor between the south side of R60 and the west side of R61 and 62, or the common terminal of both resistors, which connects directly to pin 10. On this particular board, I've already removed the modulator so that I could install my HDMI port, and you can see that I just ran the wire from here because this goes straight to that R60, and this just goes over here to the common side of R61 and 2. Also on this particular board, I ran a higher value resistor here instead of putting one in line. And that's all there is to it. With my SCART board adapter, this control voltage is expected on pin 10 and routed through another resistor to feed pin 16 on the SCART converter. And flipping the channel switch will switch the converter between RGB and composite inputs. So one final detail that I like to apply here, I went ahead and made up these little stickers that I can label this function on the switch now. I want to clean this, a little alcohol. Okay. So I'm going to cut here. Okay. And then I'm going to cut straight down the middle. And then just fold these in. And clean the backside a little bit too with my alcohol. So hopefully this will wrap around and help it stick. So there we have our little RGB composite switch label. We flip it towards the composite to get RGB. We flip it towards the HDMI to get composite. Of course, it couldn't be the other way around, but whatever. As long as it functions. The other thing, I wish the switch would stick out a little further than it does, but I don't have a replacement that will do that. So. Alright guys, well that's basically it for this video. I know I said I would do some video comparisons of the output of the different upscalers, but this video is already getting pretty long and I still have to shoot all that footage, so I'm going to go ahead and wrap this one up here, and I will save those comparisons for a future video where I can do a more thorough job and it not make this an hour and a half long. So thanks for watching, and Coco every day. Cheers.